I wanted to say good morning to those of you that have logged on early and have hung on with us for a few minutes here. We're all set to get started here in just a short period of time. We've got two great speakers today, and today is the 6th installment of our Take Action webinar series. This series is designed to bring you valuable information on weed and herbicide resistance management topics. It's a collaborative effort with the Take Action program and several land-grant university weed scientists. Joining us today, we have Dr. Kevin Bradley and Dr. Joe Ikley. Before we begin, I'll provide a little more information on the Take Action program, but the first thing I'd like to do is welcome Dr. Kevin Bradley to the program. Kevin, welcome to the program. You doing okay this morning?
Everybody that's joining us, and glad to be here and talk to y'all today.
Thank you, Kevin. And Joe, do we have you logged on? And we're looking forward to having you today. How are you doing?
I'm good. Just want to thank everyone for logging in and looking forward to the next hour.
Okay, great. About Take Action, farmers' freedom to operate is being threatened by the increase and spread of herbicide resistance. The consequences include short and long-term economic challenges, decreasing land values, and the uncertain regulatory pathway to access crop protection tools, crop losses, and other challenges. Take Action is a farmer-focused education platform designed to help farmers and their advisors manage herbicide, fungicide, and insecticide resistance. The goal is to encourage the adoption of management practices that lessen the impact of resistant pests and preserve current and future crop protection technology. Take Action is brought to you by the Soybean Checkoff. For more information on Take Action, visit www.iwilltakeaction.com. As a reminder, during the course of these presentations, you may submit questions to the chat box, and we will allocate time at the end of both presentations to address the questions. Our first presenter is Dr. Kevin Bradley. Kevin Bradley is a professor and state extension weed scientist in the Division of Plant Sciences at the University of Missouri. Kevin is a native of Virginia and received a BS degree in agriculture from Ferrum College and a Ph.D. in weed science from Virginia Tech. Kevin's faculty appointment includes extension and research responsibilities in the area of applied weed management in corn, soybean, wheat, pastures, and forages. By far the largest percentage of Dr. Bradley's research and extension efforts for the past 16 years in Missouri have been directed towards the development of strategies for the management of glyphosate and multiple herbicide-resistant weed species like water hemp. So Kevin is our first presenter today, and I'm going to turn the floor over to Kevin.
All right, thanks, Bill. I guess the task that's been assigned to me is to talk to you all about where we are in the U.S. With some of these seed destruction technologies on combine implements, and so I'll just point out that let's make sure this it's not seeming to whoa. I'm not sure what's happening there, but we'll get it on the right slide here. Just bear with me for 1 second. I think we're on track now. If I can go back a couple more. One more. Okay, sorry about that. I'm not sure what happened, but this I don't know how many on the phone is kind of a new concept to you all, but it's really not a new thing. This idea originated with a farmer in Australia. They have had historically plenty of problems with resistant weeds, primarily ryegrass, that they cannot control with just about any herbicide anymore. So Mr. Harrington worked with the university there and eventually came up with what we all know now as the Harrington seed destructor. Initially, that was a pull-behind unit, And I guess over the course of the past decade or so, it has really evolved to a whole lot more than a pull behind unit. It is now integrated into the machine, and there's several companies that are providing these. And if you're not familiar with the concept, this is a slide from Dr. Barber, and I should have mentioned at the outset that a lot of what I'm going to say today is kind of a combined talk from Dr. Tom Barber and Dr. Jason Norsworthy at the University of Arkansas. They are doing some work with integrated Harrington seed disruptor in Arkansas, and we have a different unit. We have what's called the seed terminator, and I'll explain a little bit more about those in a second. But so all the comments are really, and some of these slides are from their experiences, and some are from mine. So the kind of the animation on the screen is showing you what the concept is basically if we can get the chaff into a hammer mill or a rolling cage mill that breaks that up into much smaller pieces through a series of high revolutions. We're usually talking about 2,500 or so RPM, depending on the machine. And you have stationary bars that are there to catch all that chaff and seed and everything, and they are further degraded through that. And then what comes out of as the product is hopefully seed that is no longer viable. And so that's kind of the whole concept. It's been tested a lot in Australia with ryegrass, really not a whole lot with much of any other U.S. weed problems. And so that's where we come in over the past year or two. Actually, our research has only we've only been involved in this since 2019. But I think Dr. Barber and Norsworthy had theirs in 2018. So all of that to say that this market is really taking off. It's not so much in the U.S. yet. I think that's what we're trying to do, is trying to understand all these machines. But so there's several that are now coming onto the marketplace in Australia. One of them is Weed Hog. I'm learning a lot as we go about all the new startups that are coming out there and trying to put a machine on the market. ReadyCop is one I just heard of within the past 2 or 3 months. And I think, if I'm not mistaken, they have a relationship where they're working with John Deere, and it's even an option in Australia on a John Deere combine. So that's a little bit different from what I've heard out of the other companies, where usually with the other companies, they are basically selling it independently and allowing it to be put into any combine that you have. And so we're going to see how all this stuff kind of evolves over time, and just keep on watching Australia for all of that. But it is a rapidly moving market right now. There's a lot of interest in it. As I said, these are just some pictures off the Seed Terminator website and some marketing and explanation of how it all works. We were thankful to work with Seed Terminator, and I should say Case IH. We're kind of, like I said, very fortunate. We're leasing both the combine and the unit from these different companies and evaluating it in Missouri, and so this is just another option on the marketplace in Australia right now. They have numerous units commercially out there in the field running right now, whereas I just don't think we're there yet in the U.S. And hopefully that's because our growers are going to wait to see what our research shows that USB is funding, and we'll be able to give you some answers. So if you want to kind of see I don't know how good the videos are going to run. It might be dependent on your computer, but I do have numerous videos in these slides here, and here's our machine running, and just trying to show you that if you can see it, the stream of dust running out of each side of the back of the combine is in fact what's coming out of the seed terminator. So you can see it really does generate quite a bit of dust compared to a normal combine that doesn't have one of these units running. And in our particular device, the seed terminator, the air and the dust and all the product coming out of the back is directed right behind both tires, kind of low down on the back side. But each unit seems to have different ways they're configured and how they eject the stuff out of the back. So this is just ours running in the field though, so you can kind of get a feel for what we're looking at. And this is one of our field locations where we were harvesting anywhere from 30 to 60 acre fields in Missouri. These are farmer fields. We couldn't have done it without their cooperation, letting us do the research. So all I've got for you today is just 4 or 5 just kind of high level points, and that's really, I think, where we are. So I call these my impressions. I think Dr. Barber and Dr. Norsworthy would agree with everything that's being said here. We've discussed what their results have shown and what my results have shown, and so this is kind of one of our biggest impressions so far is basically that, you know, ryegrass in Australia in wheat is one thing, but that's not necessarily the pigweeds, the amaranthus species in soybean in our environment. And one thing we have learned is the earlier the frost, the better. If you're in the mid-south or lower in the U.S., and you don't typically have very many frosts while you're in the middle of harvest season, these things have proven to be challenging so far. So any greenness in the weeds, any moisture content, really might be an issue that we need to work through. It's not saying that we're going to abandon these whole implements and this whole idea. It's just that we might need some more modifications to try to make them work in U.S. agriculture. My first experience with that was actually we got our implement and into the combine and installed and everything in late June of 2019. We had a field of wheat that wasn't harvested just down the road from our main research center in Columbia, Missouri. I asked the farmer, can we see how this thing would work, just to try to set it up. Obviously, we weren't really looking too much at weed seed or anything. It was just more of a issue of can we harvest wheat and make everything work right. And so this kind of gives you the idea of what the field looked like. It was, unfortunately for us, a field that had a lot of water hemp in late June that was, say, 10, 12, 18 inches tall. It just varied depending on where you were in the field. But there was a lot of greenness out there, I guess is what I'm trying to say, and that did not go over well at all. We went about 100 feet in the field, and it clogged up. Now, I do want to point out that this was in wheat. We never clogged in soybean in our harvest in Missouri. And I should say that, you know, everything requires, you know, modification and research and adjustment, and this is no exception. While we did clog up, we spent, you know, about a day trying to adjust the combine, adjust the seed terminator, and figure out how we could do this. And we did eventually harvest the rest of that field with the terminator on, and did not clog up again. So I think it's just part of the learning that we're going to have to go through with these devices. But really, that whole experience went into my, I guess, fear of what would happen in soybean in the fall. But as I said, we did not have any problems with the seed terminator clogging up in any of the fields we harvested in Missouri. On the other hand, Dr. Barber and Dr. Norsworthy, they did experience some similar problems in soybean. Of course, Arkansas's where they were harvesting is further south in Columbia, Missouri, and the pigweeds were still green, and it did not go over too well, at least for some portion of the research they've been doing. And they sent me pictures very similar to what we had seen with what happened to us in wheat. So it is a hurdle that we're still working on overcoming. And I guess the good news is if you're in a geography more northern, more Midwest, and further north than that, this probably is not going to be an issue for you. The earlier you get the frosts in relation to your harvest, the better it would be for these devices. But we're still working on it. Dr. Barber also, just like what I said about we did eventually get it working, he was quick to point out that once they had a killing frost, everything worked great. And this is his video that he sent in his slide. And as you can see, they've got pretty weedy palmer field. They had a frost and they were able to get on through it. So they are investigating some desiccants and other things that maybe could be done, but who knows? Maybe there's some more engineering that could go in here that would help with some of those issues. All right. So the second impression that we've had in our research is, and this is a slow motion video of a combine header going over velvet leaf and soybean. And the second impression that we have seen is that not one that's been talked about a whole lot, but there's going to be some degree of header loss of weed seed. And we just feel it's important just to put that out there, not to give anybody any misconceptions that there's not, because we're going to be doing more research in this area to determine if frost influences that likelihood to shatter and maybe lose more than what you can get in the combine. And who knows what are the things that we can evaluate here to try to get more of it into that header. But our data shows that with water hemp, which was a primary weed we harvested, and some of the others, that when that reel hits it, it is some portion of it, although it might be small, there is some portion that does get lost. The third thing that I've found just in the 4 fields we've harvested and the research we did in 2019, and this isn't really, I don't think, that surprising to everybody that's associated with running a combine before, is that there is going to be some weed seed loss out of the straw chopper and all of that as well. It doesn't all get directed to the seed terminator. Now maybe that's another area where we can improve upon and get more going into it, but there is, again, I think it's going to be a minimal amount, and our data says it is a minimal amount compared to how much goes in the seed terminator, but some weed seed does get lost just from the straw chopper. And this picture is actually some of the trays we put out behind the combine, and you can see all kinds of chaff here and everything else. But if you look close enough down in the metal pan, you do see a bunch of black specks, and that is some water hemp seed. So the good news is, this is our fourth impression, and it's kind of wordy here, but most of the weed seed does go into the seed terminator. So I don't want anybody to get discouraged by what I've said so far, because I think the vast majority is going into the seed terminator, and maybe there's some things we could do to direct even more of that seed into the terminator. The other good news is whatever we catch that's coming out of the seed terminator is almost certainly not going to be viable. I can't say that with 100% confidence yet, but we are doing that research and going to have answers as soon as we can for that. But so what you see on the screen is two sites worth of data. We've done 4 sites. We don't have all the data from all 4 yet, but here's just 2 of our locations. And as you can see, first of all, like I said, the vast majority of seed are going into the terminator. As you can see here, we're in the 200,000s and the 100,000s with the amount of seed. And like I said, the other good news is that the vast majority of it is damaged in some way. And we're pretty conservative about what we call damaged seed, and I'm pretty confident that it will come out that it won't have any germ to it. So we'll just have to wait and see on that. The other thing I'd say that's really not on the screen is we focused on water hemp, obviously, but anything bigger than a water hemp seed, which is pretty much all of our other weed seeds, is kind of a no-brainer. They get ground up into complete dust, and you can't even hardly determine what seed it was. For example, foxtail and velvet leaf, we had some fields with those, and I think the results are going to be pretty clear that it will certainly crush all of those that you probably won't even have any. So we'll just see what our final data says about all that. So here's just some pictures of what we call, basically, if greater than 50% of the seed coat was gone, or if the seed was half the size of a non-damaged seed comparison, then we called it damaged seed. So most of the seed was very damaged, as you can see here, and I do not believe it will be viable, but still more to come there in the future. So I think the last impression I have is number 5 here, and that is just some engine performance data and combine performance data that we have been able to gather. Quite frankly, we've been able to gather that just because of all the computers that are inherently in combines nowadays. So we did do some comparisons, and for us, we have a Class 8 combine that Case has allowed us to lease and work with on this, and if you're running it, you can't really feel any difference, but the numbers in the computer that are engine load, whatever that means, the stuff that it's analyzing just inside that combine, it does differentiate, and you can tell the difference when you start looking at these numbers. As you can see here, we have an engine load of 61% when it's off versus 96% when it's on, 85 and 100 and all of that. So obviously it is gonna be more fuel per hour that you're expending. That seems pretty clear, and I think the jury's still out on speed. It might slow us down just a little bit, but we actually didn't have real definitive results from that first site, and we'll just see how that works all out. But it's not much different. It might slow us down just a tad, but if we're able to guarantee we're not putting seed back onto that soil, I think probably it's going to be worth it, and that's what the Australian farmers are saying so far. So the last slide, well, almost the last slide I have is I firmly believe that any tool that we have in this country that keeps seed from going back onto the soil is going to be valuable. I think we still have much more work to do to see how these are going to fit U.S. agriculture, and that there's probably still more modification that can be done by smart people and engineers and things like that might even make it even more fitting. And I do want to acknowledge USB funding for this project. Without it, we wouldn't be able to do it. And as I've already said, certainly want to acknowledge the Seed Terminator Company and Case IH Global for getting on board with us and just allowing this to happen, because there's a lot of moving parts, a lot of very expensive equipment, and it takes a whole lot of people to try to get these results. So with that, I am done, and I will obviously be on the line and hear from Dr. Ikley, but I'm going to turn it back over to Bill.
Okay, thank you, Kevin. Interesting stuff. Our next speaker today is Joe Ikley. Joe is a native of Maryland. He received his BS in Ag Science and Technology and his MS in Crop Protection with a focus on weed science from the University of Maryland. Joe worked on his Ph.D. in weed science at Purdue University, and during his time at Purdue, Joe also worked as a research associate and as an extension specialist while he was working on his degree. Joe started as an assistant professor and extension weed specialist for North Dakota State University at the end of 2018. He has statewide extension responsibility for all crops except potato and sugar beet. His research program focuses on managing difficult to control and herbicide resistant weeds in corn, soybean, and dry edible beans. So Joe is our next presenter, and Joe, I will turn the floor over to you.
Okay, thank you, Bill, and thank you, everyone. Let's see if I get control here. There we go. All right, so my topic today is going to be dealing with some issues that we ran into with the Enlist soybean system in North Dakota in 2019. I kind of became the de facto expert on this. We had a meeting with weed scientists last fall, and I asked the other weed scientists if they'd experienced these tank mixing issues, and the blank stares I got back let me know that no one really knew what I was talking about, and that we were probably a high adopting area of Enlist soybean. And so I'm going to go through some of the issues that we ran into in 2019, and then really try and get this on everyone's radar so that nobody else experiences the issues that we had in 2019 as we look forward to the 2020 growing season. So first, by some way of some background, if you are not familiar with the Enlist system, we were first able to commercially plant Enlist soybeans in 2019. The Enlist trait itself gives tolerance to glyphosate and 2,4-D choline, but most seed companies are going towards this Enlist E3 soybean, which also gives us tolerance to glufosinate or Liberty. So glyphosate, glufosinate, and 2,4-D tolerance in the E3 soybean system. There are two 2,4-D choline products currently on the market. Enlist 1, which is the straight goods 2,4-D choline, and then Enlist Duo, which is the choline plus a glyphosate. These herbicides have been available for several years, but now we also have the soybean system to go along with them. As with the Extend system, anything we throw into the tank as a tank mix partner has to be on an approved list. So if you go to enlisttankmix.com, you'll see you can either click on Enlist 1 or Enlist Duo, and it tells you all the approved tank mix partners. Now, with the tank mixing, and I do want to recognize any slide that has this Corteva in the bottom left corner, they are slides from Corteva. We've worked together to try and get some training implemented this past winter. So with Corteva's slide here, it's really important to know with the Enlist tank mix system that all qualified partners only go through the EPA protocol for drift testing. So making sure that a tank mix partner does not increase the amount of driftable fines. On the right side of the screen is all things that are not tested to be an approved tank mix partner. And I'm really going to focus today on the second bullet point. These are not tested for physical tank mix compatibility. And that's what most of my presentation will focus on, is some of these tank mix compatibility issues that we experienced in 2019. So again, just to emphasize, the reason that we're really focusing on this topic here today is that Corteva has announced that they anticipate having the E3 soybeans on up to 20% of U.S. soybean acres in 2020. So that's a higher adoption rate for many people. That's probably about where we were at in North Dakota last year, but certainly ramping up the use of this platform nationwide. So a couple of things that I can talk about for the Northern Great Plains from 2019. We did have fairly high adoption levels, certainly North Dakota, but also I'd say Northeast South Dakota and Northwest Minnesota as well. My estimate is about 20% of acres. That's not any number from Corteva. It's basically just my estimate based on talking with people, realizing that our water hemp and common ragweed acres, we had relatively high adoption. So I'm thinking statewide about, but 20% is what we had in 2019. The other thing that we learned is commercially, the Enlist 1 product is a lot more popular than the Enlist Duo product. A couple of reasons here. With the Enlist 1, which is again just the straight 2,4-D choline, you can use your glyphosate product of choice and your glyphosate rate of choice. With the Enlist Duo, you're basically locked into the glyphosate rate that the rates of the Enlist Duo product allow. And then as far as tank mix partners, we can legally tank mix glufosinate with Enlist 1. Currently, we cannot do that with Enlist Duo. So commercially, Enlist 1 was by far the more popular product. The other thing we had, which is not too different from any given year, but we had about a 2-week window in June where most of our post-emergence applications went on. And so that's when we ran into a lot of issues, and late June, we had a lot of these tank compatibility issues pop up. And so that led to, I wrote an article for our crop and pest report in early July, and this is kind of where this compatibility testing started. And so I'm going to show a couple pictures from that article and then some more jar testing we've done over this past winter. So what we basically did, the feedback we were getting is the potassium or K salts of glyphosate, such as Roundup Power Max, were salting out and leaving residue all over spray tanks and screens, and especially in low water conditions. So what we did is, from left to right, we've got a potassium salt of glyphosate and then a DMA, dimethylamine salt of glyphosate. In this case, these two jars are 1 gallon carrier, the middle is 3 gallons, and the far right is 15-gallon carrier volume. And indeed, what we saw in low carrier volume when we had the K salt of glyphosate and Enlist 1, a lot of white chalky residues and salting out of the solution. Once we had a higher water carrier volume, we did not have these issues. So of course, some of the things we ran into commercially is with something like an inductor cone. So adding the products right after each other, and that's when we got a lot of these compatibility issues. And just a couple of close-ups from that initial jar test we did. Again, the K salt on the left, DMA on the right, and just really showing some of the chalky residues that we were leaving behind compared to when we started with plenty of water. So where that leaves us today, at least as of last night, if you go on the Enlist tank mix for Enlist 1, the left side of the screen is all the current approved glyphosates that we can use with Enlist 1. And I just point out, I just picked 3 just to show that we do have 3 different salts available. These are the 3 salts, the DMA, the IPA, and the K salt that comprise all of the different glyphosates on the left side of the screen. So what we did, we chose, because we did not test the IPA salt this past summer, we wanted to take a closer look at that. And we just looked again at these salts. In this case, this is the equivalent of 5 gallons of water carrier. DMA on the left, IPA in the middle, and then that K salt on the right. And this is about 5 minutes after adding glyphosate plus Enlist 1 into these tanks. So to really focus in on what's happening as soon as 5 minutes, well, certainly earlier than that, but these pictures were just 5 minutes later, of what's happening with the K salt and Enlist 1. And if we zoom in even further, we'll just see the formation of individual salt crystals as it's falling out of solution and then eventually settles into the bottom of our tank here. If we come back 1 hour later, so we mixed these products, shook our bottles, and then let them sit for an hour. The DMA and the IPA salt were still fully in solution. Our K salt now, we had pretty clear separation of our salted out residues on the bottom, and then a solution resting above that. The other thing that I'll mention here is we tried a number of different ways to rescue these K salt plus 2,4-D choline mixes once we had salting out, and we weren't really able to get that back into solution. Even adding a lot of water, once you get that formation of those crystals, or as we called it commercially, cottage cheese, once you get that, then we were not able to get these back into solution very readily. The other thing that we honed in on later in the summer is we're also having issues with AMS. And specifically, so I guess I should back up. With the Enlist system, we do have the ability to use AMS or ammonium sulfate. That is different than the Extend system. And where we run into issues with AMS is when the AMS was not fully dissolved into the water solution before the 2,4-D choline was added. So here's just a couple pictures. We tried to test that system, added AMS, then added 2,4-D choline before it was fully dissolved. And here's the same type of residues that we're seeing, that white chalky mess from the 2,4-D choline is salting out. And based on the AMS source, we did get some different, I guess, pictures here to look at of some different salting out formations. But dry AMS, a lot of small crystals. One of our liquid AMS products, we got some longer crystallization. But either way, we tested 3 different approved AMS products and had the same issue when we added the 2,4-D choline before allowing the AMS to fully dissolve into solution. So where that leaves us after the trials and tribulations of 2019 heading into 2020, here's the official tank mix procedures released by Corteva. And so most of this is very typical for all other herbicide mixes that we do. I want to point out step 7, they do have something here in bold, is that when mixing Enlist 1, do not pour the glufosinate or your Liberty products or glyphosate potassium, those K salts, into the tank the same time as Enlist 1. So basically add products one at a time, allow enough time for recirculation. More or less what Corteva is recommending. Anytime you add a dry product, give it 5 minutes to mix in. Anytime you add a liquid product, give it at least 2 minutes to thoroughly mix before adding the next product. So really slowing down, letting things thoroughly mix, and that's really where we want to go with these systems, especially if you do want to use your potassium salt of choice, knowing that these issues do exist. So 2 additional things that we looked at. I wanted to look at glufosinate compatibility with 2,4-D choline, and I was not able to replicate any sort of salting out process. The picture on the left is 1 hour after mixing. The picture on the right is 4 days after mixing. We did get a ring of salts, but we shook up this bottle and got everything right back into solution. So I was not able to replicate any issues with glufosinate and 2,4-D choline. My guess is AMS was in the tank and we were running into issues with the AMS component, not actually with glufosinate as far as compatibility. The other thing I wanted to show here, when we fully follow the procedure, so in this case, focusing on the bottle on the right in both pictures, this is a ultimately 10 gallon per acre carrier volume. We started with about 7 gallon equivalent in the bottle, added AMS, let that fully dissolve, added our K salt, let that fully dissolve, and then added the choline and topped it off up to 10 gallons. And we had a full solution 1 hour, and then 4 days after mixing, we basically had these products still fully in solution. So we can, if we start with plenty of water and have patience, we can overcome this physical compatibility even when mixing with AMS and K salts of glyphosate with the 2,4-D choline. And so here's just a couple of Corteva's recommended slides showing some of the issues that they ran into on the commercial scale in 2019. And this really just repeats a lot of the things that I said. If you do want to use the potassium salt, just start with the clean sprayer, plenty of water, at least half a tank full. I'd probably recommend a little bit more than half a tank full of water, just to allow for more dilution. And certainly take your time while mixing. If you do have a cold water source, allow for a little bit longer time to mix products. And again, just kind of a repeat here of that last slide, but just showing some more of the issues we ran into on commercial strainers in 2019. So that's the message on the compatibility. The other thing I want to take a little bit of time to talk about today, and not in too much depth because Dr. Bill Johnson covered this in more depth last week, but as far as antagonism that we might expect with the 2,4-D, the Enlist system. And I'm really going to focus in on the second column here, is that when we mix our group 1 herbicides with Enlist, we will have antagonism on grass. So the official Corteva recommendation is to, whatever your use rate of choice is for your grass product, increase that by 1/3 to overcome antagonism on our target weed species. And they have some more guidance for volunteer corn, knowing that clethodim or select is going to be the choice across most acres for volunteer corn control. This chart here on the bottom right just kind of shows their different recommendations of the rate of select to use when tank mixing with Enlist 1. And so I want to show some research here that Dr. Kirk Howlett conducted in North Dakota the past 2 years, looking at specifically the Enlist choline, Enlist 1, with 3 different graminicides, in this case, Assure 2, Fusilade, and Select. And the way we read this chart, we have 4 bars within each product. The hashed green bar is just the graminicide alone at a low rate. And so the rates are below each product name. The red bar that's next will be that same rate plus 2 pints of Enlist 1, and then a middle rate plus 2 pints, then a high rate plus 2 pints of Enlist 1. And so you can see with each different product, if we keep that same rate and add Enlist 1, we do lose control, in this case on volunteer corn. And it really takes that high rate to get equivalent control, and we only saw that with Fusilade and Select. Assure 2, we were never able to achieve the same control even with our highest rate. So just looking at this in picture form, 3 slides of pictures, then I'll be wrapping up here shortly. Top picture is the graminicide alone, and then the bottom left is that low rate plus Enlist 1, the middle rate plus Enlist 1, and then that high rate plus Enlist 1. And so you can see with Assure 2, we basically have no symptomology until we get back up to that high rate when tank mixed with Enlist 1, and still not as great as the product by itself. Similar story with Fusilade, just a little bit more activity on the corn. And then Select, overall better activity on volunteer corn, but again, it really took us getting to that high rate with the Enlist 1 to get acceptable volunteer corn control. So just an overview of the things I've briefly covered today. When the compatibility issues that we discovered on the commercial scale and then in our jar testing inside is those potassium salts of glyphosate, and then using AMS, especially when it was not fully dissolved in water. So the recommendation is to overcome those compatibility issues. Start with plenty of water, at least half a tank. I'd go a little bit higher than half a tank just to get more water in there. 2 to 5 minutes mixing time for each product. If you do use inductor cones, add 1 product, flush a couple gallons of water in between each product along the way. And of course, the other thing, these are just the tank mix partners that we tested. If you do have any concerns, you can do your own jar test, kind of what I showed, what we did in the lab, and see if you have compatibility issues with different products as well. And then for the grass antagonism issue, certainly raise the rate of our group 1 herbicides. We did see with Assure 2, we weren't able to get equivalent control. So realizing that you will have some issues with grass control with the tank mix of those 2 products. So with that, Bill, that's all that I had. And I think what we do now is move forward to questions for both Kevin and I, if I remember the proceedings.
Okay, thank you, Joe. Great presentations by both speakers today. I've got a couple of questions here that showed up in the chat. So I think, Kevin, I'm going to go to you for the first question. So Kevin, do you have any views or opinions on adoption rates of seed terminator type of machines? And maybe just kind of give us your thoughts there, because you've had the chance to work hands-on with these growers, and kind of tell us some of the things you've learned as far as potential adoption rates.
Yeah, great question. I think it's obviously going to be interesting to see what happens with all this in the future in the U.S. Most of the companies have been pretty adamant that they're not necessarily looking to partner with a particular combine manufacturer, but rather they are interested in selling their device so that it can be put in any combine. Now, maybe that'll change depending on how all these relationships evolve and all of that. It looks like it kind of already has changed a little bit in Australia when you have the Redicop being offered on John Deere only. At least that's my understanding. But the farmers that have that I've talked to about this or worked with, or seen it in action, they're very interested. I think even some of our, perhaps maybe what the greatest interest I have so far of people calling me and asking is from the crowd that's growing non-GMO soybeans or maybe even organic soybeans, and just kind of has more of a need. So we are getting a lot of questions from that kind of clientele, those that are getting a premium. But it's probably going to depend on a couple of things. Price, what are the prices of these things going to be whenever they do make it into the U.S.? I think that's still a big question mark. And then, it's probably going to be dictated by geography after that. We have plenty of water hemp problems in Missouri, and I know pretty much throughout the Midwest and other states as well. The South has plenty of problems with palmer. I would expect, just based on that alone, that we'd see a more tendency of adoption in those areas first, for sure.
Okay, all right. So Joe, I'm going to go to you next. So are there any other products in the Enlist system that we should be cautious of in terms of this tank mix issue? So I think you did a really thorough job of covering the K salt of glyphosate. But are there any others where we need to take extra care with our mixing order, mix times, carrier volumes, and things like that?
Yeah, a good question there. And so the majority of issues that we hit this year were the case of glyphosate, and then certainly the AMS issue was probably a little bit worse than we initially thought, just not having that fully dissolved. There has been some issues with some dry products. So there's a couple we'll use post-emergence in soybean, but certainly if we're using pre-emergence and burn down, that's kind of why Corteva's recommendation is at least 5 minutes after any dry product to let that go thoroughly into solution. So that's at least where we're at now. There's of course a couple hundred products on that approved list, and I don't have the capability to test all of them, but I'm sure we will run into some other issues along the way, and that's why it's just a good idea to do one of these tank mixes like jar tests like we did if you have any question about products. But certainly dries maybe some of our micronutrients, but without testing them, not entirely sure.
Yeah, this is Mark Laux. The other thing is, I don't know if I saw it in your presentation, but the glufosinate really can't go with Enlist Duo. It's not approved for that, right? So anything that's getting any mixes that have involved Enlist with glufosinate, it has to be Enlist 1, right?
Yes, correct, Mark. Yeah, so Enlist Duo, we can't use glufosinate, and the marketplace has kind of reflected that up here. We're probably on our acres 90, maybe 95% Enlist 1, just because of the more flexibility with tank mixes.
Okay. All right. I think we're, and Mark, unless you have any additional questions, I think we're kind of at the end of the list of questions we have.
I think whether we had some antagonism, and you touched on it. We did a little bit of work so far with the glyphosate, glufosinate, and the 240. And aside from mixing issues, I think we still have a little bit to learn about possible how, for example, glyphosate and glufosinate interact and how that's affected by growth regulators. There's been some inconsistent results in the field, I think, depending on what all's in the mix. So I think we're going to learn a little bit more about that as we go along.
Okay. Joe or Kevin, do you guys have any final comments?
None here, Bill. I think I hope if anybody has any questions, they'll certainly feel free to send through email or give me a call.
Same here. Just echo what Kevin said, and also thank everyone for listening in, for those who have logged in.
Okay, well, big thanks to both of you. This wraps up today's presentation, and a recording of this webinar will be available on the Take Action website within a week. Next week, we'll have our 7th Take Action webinar, and we will have Dr. Mandy Bish from the University of Missouri and Dr. Brian Young from Purdue as they discuss weather effects on dicamba and dicamba off-target movement research. So I'd like to thank everybody for joining us today, and we look forward to doing this again with you next week.